Hey guys, previously we looked at how to create an equation from a graph, and now we are looking at how to do it from a table. So I know that you guys have this handout and you're following along. So the first thing we see is it's our linear form of an equation, y equals mx plus b. We call this slope-intercept form. The first part of it is m, this is our multiplicative piece, and then we have b, which is our additive piece, and we call that our initial value. In order to write an equation, those are the only two things that we need to find. So the first one was m, which is our rate of change. And the next was b, which was our initial value. And guys, keep in mind our rate of change is that comparison of the change in y to the change in x. If you see the triangles like this, all that means is change in y over change in x. So let's apply this. When we have a table and we're asked to generate an equation, that's just our rule. It's our rule from how we get from our input to our output. I know that our rule will be in the form y equals mx plus b. So I will need two pieces of information. I will need to find the rate of change, and I will need to find the initial value. So the first strategy that I would recommend is to create a table that has actually 3 columns. It has your first column, which is x for your input, and then it has your process column, and then it has y, which is our output. Now our process is that mx plus b. It's what are we multiplying the input by, and then what are we adding. So I'm going to complete and fill in the coordinates in my table. And actually right here, this 10 is a typo. It is supposed to be an 11. So go ahead and change that. And I know when I'm given coordinates and pairs, a sets of ordered pairs, I can find the rate of change by comparing the change in y to the change in x. And so I see that from 3 to 5, I increased by 2. So that change in y was an increase of 2. When my y increased by 2, x went from -1 to 0, so it increased by 1. So 2 over 1 just simplifies to 2, and that is my rate of change. That is that multiplicative piece. So when I look back at the process, I know that that's what I'm going to multiply my input by. So 2 multiplied by -1, which is the input. Well, 2 times -1 is -2. And I need to know how I get from there to the output of 3. So if I draw a number line, and I'm at -2 right now, to get all the way to 3, I can add 2 to get to a friendly 0, and then I can add 3 more to get to 3. All in all, I've added 5. So I needed to add 5 more to get to my output. So let's try it with our next input. So I'm still going to take that rate of change, which is 2, multiply it by the input, which is 0. Well, I know 2 times 0 is just 0, but I need to get to 5. So I need to add 5 more. And I can look to see if the pattern continues. So 2 times 1 is 2, plus 5 gives me 7. 2 times 2 is 4, and plus that extra 5 gives me 9. 2 times 3 is 6, plus that 5 gives me 11. So every time we have this pattern where I'm multiplying by 2, which is the rate of change, but then I'm having to add on 5. So that's the constant. That's the thing that doesn't change. That's my initial value. So I can take those two things, and now I can write my equation. Y equals 2 times x, which is our input, and then plus 5. Let's look at one more. Again, I know that I want to write an equation in the form y equals mx plus b. So I will need to find my rate of change m and my initial value b. So I'm going to create that table that has 3 columns for my input for the process, which is the mx plus b portion, and then the y, the output. I'm going to transfer over my coordinates. And now I remember that if I have all my coordinate pairs, I can find that rate of change. And that rate of change, which is the comparison of how y changes as x changes. And so I see that y goes from 10 to 7, which is a decrease of 3. And then as y decreases by 3, x increases by 2. So I can leave this rate of change as a negative 3/2, or I can also put it as a decimal of negative 1.5. Once I know the rate of change, I can go look at the process. So if I have negative 1.5, which is that rate of change, and I'm multiplying it by the input of negative 2, I need to know how to get from there to 10. A negative times a negative will give me a positive. And so now I just need to know what 2 groups of 1.5 is, which will just give me 3. So if I'm at 3 and I want to get all the way to 10, I need to add 7. So I add 7 more to get to 10. And now we want to look and see if that continues. So negative 1.5 times 0. Again, anything times 0 is 0. Plus that constant of 7 to give me my output of 7. Okay? Negative 1.5 times the positive 2. So negative times a positive will give me a negative. So that's a negative 3. I want to get to 4. If I add 3 to get to 0, and then I add 4 more, now I'm at my output of 4, and altogether I added 7. And it works with the remainder of my inputs. So negative 1.5 times 4 is equal to negative 6, plus 7 more, and we get that output of 1. Negative 1.5 times positive 6 gives us negative 9, and then we add 7, and that takes us to negative 2. So again, when we look at our patterns, every time we're multiplying by negative 1.5. But then we have to go and add 7 on. So when we write our rule or our equation in the form y equals mx plus b, it would be y equals negative 1.5 times x, which is just our input. But then we have to add on the 7. All right, and there we go. Have a good day.